A second example of being able to work with variation of parameters, y double prime plus 3y prime plus 2y equals sine of e to the x. Once again, not a simplistic function that we have for the right-hand side, so probably variation of parameters might be a little bit more efficient than trying to guess something that's not as obvious. Let's quickly go through the complementary solution to this. Auxiliary equation, m squared plus 3m plus 2 equals 0, factoring into m plus 2, m plus 1, and so we get two distinct m's, -2 and -1. And so our complementary solution is going to be c1e to the minus 2x, c2e to the minus x. This is important because we also need the variable parts, the variable factors of yc to generate y1 and y2. So y1 e to the minus 2x, y sub 2 e to the minus x, and then f at x, the whole genesis of having to do this, is sine of e to the x. Alright, so hopefully this works out nicely, but if not, then we have to rely on our integration skills. Alright, so now we're going to find w, w1, and w2. W is the determinant of y1, so that's e to the minus 2x, and then y2, which is e to the minus x, and then their successive derivatives, so -2e to the minus 2x, and then -e to the minus x. Remember, to find a determinant, cross down, cross up. So we're going to get -e to the minus 3x minus a -2e to the minus 3x. And when that all settles down, that just becomes e to the minus 3x. W1. W1 is equal to y1, y prime 1, and then 0, and then f at x. All right? And again, just to remind you where we're getting these formulas from, we just go all the way back up here, and remember our formula for W1, I think I botched that, so I'll recopy that, but these are where we're getting our formulas from. So let me go back down, I'll reconstruct that. All right, so apologies. All right, so for W1, we have f at x 0, and we have y2, y prime 2, 0 f of x. I'll get it right soon. So 0 and f of x, and then y2, y prime 2. All right, so 0, and then sine of e to the x. Y2, remember, was our e to the minus x, and then the derivative, -e to the negative x. All right, so if we go forth and do our cross multiplication, that cancels 0 going down and then going up, so we get 0 minus e to the minus x sine e to the x. Right? Or in other words, just a -e to the minus x sine e to the x. Right? And then finally, we need W2. And remember, W2 is y1, y prime 1, 0, and f of x. All right. And I'm just going to scroll up just to make sure I copied it down correctly. Yep. Okay. So when we compute, remember y1 was e to the minus 2x, and the derivative -2e to the minus 2x, 0, and then we have our sine of e to the x. And this one's pretty easy. That's just going to be equal to e to the minus 2x sine e to the x. All right, so we're going to go ahead, we're going to find u prime 1, which is equal to w1 over w. Remember, w1 was negative e to the minus x sine e to the x. And w, I believe, was e to the 3, or e to the negative 3x, I believe. Yep, right here. So that's e to the minus 3x. And when we divide that out, that just becomes negative e to the 2x. All right, so we just subtract the exponents. Negative x minus a minus 3x is e to the 2x sine e to the x. All right. U prime 2, which we're going to like a little bit better, is going to be w2 divided by w. And that's going to be equal to e to the minus 2x sine e to the x divided by e to the minus 3x. And this time we just end up with an e to the x sine e to the x. All right. Now, the integration for this is not going to be too pretty, all right, as you can imagine. So we're going to have to deal with this, and we're going to have to deal with this. So let's just focus on one of them at a time. And remember, for our particular solution, that's going to be y1 integral u prime 1 dx plus y2 integral u prime 2 dx. All right, so let's focus on u prime 1 to start with. Okay, that's actually going to be the more difficult of the two. And I'm just going to find the integral. All right, so this integral becomes the integral of, I'm going to pull the opposite on the outside, e to the 2x sine e to the x dx. All right, so why is this so difficult? Well, it's not a u substitution because, or it's not a straight u substitution, because if u was equal to the interior e to the x, the derivative would not be e to the 2x. But we can manipulate this. All right, so we're going to rewrite this as e to the x times e to the x sine e to the x dx. So we're going to be sneaky about it, and we're going to use a u substitution. Even though it's not going to get us completely to where we need to go, it'll make it evaluable. So u is going to be equal to e to the x, du is going to be equal to e to the x dx. All right, so let's think about what happens when we're done with this substitution. E to the x dx is du. Anywhere else we have an e to the x is a u. So what we're going to end up with is the opposite of u, sine of u du. All right? And although you might not like that, you can evaluate that integral by using parts. All right, so now we've already used u's, so I'm just going to say a and b for my parts. So our formula is usually uv minus integral v du. I'm going to say ab minus integral b dA. So uv v du. Right. So I'm going to define a to be u. I'm going to define dB to be sine u du. When we integrate dB to get b, that's going to be a negative cos u, which is actually good because that's going to help get rid of the negative. And then dA is du. All right. So now the integral can be written as the opposite of ab, which is going to be negative u cos u, minus integral of b dA. So minus cos u du. Now there is a plus c in all of this. We'll worry about that at the very end. All right. When we integrate all of this, then we are going to end up with u cos u from the first part. We have negative, 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 so we get minus sine u. All right, so at this point, now we can go back and substitute for u. Okay, remember we said that u was e to the x. So we get e to the x cos e to the x minus sine e to the x. And that's going to be u1. All right, so as you can see, this is not an easy problem to work through. All right, now the other one's a little bit easier. Okay, so remember we need to find what u prime 2 is. All right, so we're going to integrate u prime 2 dx, which is going to be the integral, and we're going to go all the way back up. We're going to define u prime 2, and remember u prime 2 was e to the x sine e to the x, which is a lot easier. This one's another u substitution, so u is going to be equal to e to the x. This time du gives us exactly what we want. All right, so we're going to get integral of sine u du. Antiderivative of sine is negative cosine. And then if we back substitute, that's just going to be negative cos of e to the x. All right. So we're going to meld all of this together. We're going to get our particular solution. So yp is going to be equal to y1. And remember, all the way back up here, y1 was e to the minus 2x. y2 was e to the minus x. So we're going to have e to the minus 2x times the quantity of this horrific answer that we got before for u1. So e to the x cos e to the x minus sine e to the x. And then we're going to have plus y2, which was e to the minus x, times, we got this negative cos e to the x. All right, now, believe it or not, I believe that this is going to simplify fairly nicely, because when we distribute this e to the minus 2x, and I believe that there should be, oh no, there's not an e dx in front of that sign. Okay, so that's good. So when we simplify this, we're going to wind up with e to the minus x, since we have negative 2 and 1, cos e to the x, minus e to the minus 2x sine e to the x, and then minus e to the minus x times that cos e to the x. All right, and what you'll notice is that this term and this term are opposites. So they cancel out. So after all of that, yp is e to the minus 2x sine e to the x. And so mercifully, we can get to our solution, y of x, which is equal to y of p plus y of c. Remember, we had c1e to the minus 2x plus c2e to the minus x, and then we have this minus e to the minus 2x sine e to the x. All right. And remember all those constants that we had? The constants of integration are actually built into the answer to the function, so no need to worry about the constants of integration. Again, if you want to take a couple derivatives and verify the solution, be my guest. However, we'll just go with this. All right, so we have 2 more examples to work through. We'll get to those in the next 2 videos.